we are doing very important only. So in the first question, a student is investigating the volume of a dilute sulfuric acid that react with 25 cm cube of sodium carbonate, aqueous sodium carbonate. So student is having an aqueous sodium carbonate and investigating how much volume of sulfuric acid is needed to react with aqueous sodium carbonate. A burette is rinsed with water and then with sulfuric acid. Look, we are filling up this burette with the sulfuric acid, but first we rinse with water and then we rinse with sulfuric acid. So what is the reason why first we rinse with water? Because when we are using any apparatus, maybe that apparatus, that part of apparatus was used before in any other experiment. So that's why we always first rinse with water to remove the substance from the experiment before or used earlier. And then why we rinse with sulfuric acid? To remove the water. Because what happens when we rinse the burette with first with water, so maybe some of the water droplets are still there inside, or because water has a tendency to stick to the wall of the container. So some water might be there when we rinse with water. So to remove that water, then we rinse with a sulfuric acid. The burette was filled with the sulfuric acid and some of a dilute sulfuric acid run into a burette, run out of a burette, so that the level of a sulfuric acid was there on the burette scale. 25 cm cube of sodium carbonate was poured in the label A. So we place in we poured the aqueous sodium carbonate in apparatus which is labeled as A. The apparatus labeled A was placed on a white tile. What is the reason why we use a white tile, white background, or white base? Because normally we use indicator and indicators show a color change. So when we have a white background, it is easy to recognize the color change. But maybe, for example, if you are doing this experiment on a bench and that is dark or a brown in color, so it will be difficult to identify the color change. So whenever we are carrying out the experiment, normally we carried out this neutralization reaction or titration. We normally carried out with a white background, like even back of the burette, we should have white background, and the base also on which we are keeping the conical flask, that is also white. The main reason is that because when they have a white color, it will be easy to identify white background or white base, so it will be easy to identify the color changes which occur. But maybe if you are keeping it this conical flask on a bench and which is, like example, brown in color or dark in color, it will be difficult to identify the color change. So the main reason why we are using a tile, so it will be easy to identify the color change. Then a dilute sulfuric acid was added to 25 cm cube of sodium carbonate until the methyl orange changes the color from yellow to orange. So originally it is yellow and then it changes to orange. So why it changes from yellow to orange? Because in the beginning, the solution sodium carbonate was there, alkaline solution. But when we are adding acid, it neutralized, and then further we add all the sodium carbonate has reacted and solution become acidic. That's why the indicator shows a color change from yellow to orange. Name the apparatus labeled A. What we call this apparatus? What is the name of this apparatus? You can use the chat. You can use the chat or the mic to state the answer. What is the name of this apparatus?
Conical flask.
Yeah, that's right. It is a conical flask. This is not a round bottom flask. Round bottom flask is like this. This is a round bottom flask. For titration, for neutralization, we use conical flask, burette, pipette, measuring cylinder. These are the apparatus and dropper to add the indicator. One safety precaution that you should take while using a dilute sulfuric acid. When we are handling an acid, what should be the safety precaution? What precaution we should take? So because acid, maybe the acid spill on the hand, so you should use a gloves, or you should use a lab coat, or you should use a safety goggles. So anything you can mention here. So use goggles, use gloves. You can mention use goggles, use gloves, or use a lab coat also. So it will protect, as acids and alkalis both are corrosive. Give a reason why a white tile is used. That's the same thing as I mentioned, why we are using a white tile. So it will be convenient to identify the color change. So it will be easy to identify the color change. We can identify the color change when we are using the white base or a white background as in a neutralization reaction. Describe what should be done to the apparatus A as dilute sulfuric acid is added to aqueous sodium carbonate. Look, when we are adding acid, so from a burette, so what we should do, because to make sure that acid reacted with sodium carbonate, so what we should do, we should swell the mixture. Like we should shake the mixture or we should swell the mixture so that acid can evenly mix with the sodium carbonate. Otherwise, what happens if we don't swell the mixture, only one part where we are adding an acid, that part is reacting, other parts are not. So to make sure that all the molecules of sodium carbonate are reacting with acid, whenever we are adding an acid, what we should do, we should swell the mixture. Or we can also, you can also mention that the conical flask, so that the two solutions can evenly mix with each other. Then state why a burette was rinsed with water and then with a sulfuric acid at the beginning. So first, why we rinse with water? As I mentioned in the beginning, like we want to fill this burette with acid. So first we rinse with water, first we wash with water, and then we rinse or wash with acid. So why we first rinse with water? To clean any substance from the previous experiment. And then why we rinse with acid? To remove any trace of water present in the burette. Because if water is there in the burette, what it will do, it will affect the concentration of the acid. So why first we rinse with the water? To remove any residue from the previous experiment. And why then we rinse with dilute sulfuric acid? To remove the water, because as we are rinsing with water, some of the water will be there in the burette. And if that water remain in the burette, then the concentration of acid which we are using, that will change. Then question 2. So what is happening here? A student investigated the rate of a reaction between a small lumps of calcium carbonate. So student took a small lumps of calcium carbonate and he add hydrochloric acid. So when calcium carbonate react with hydrochloric acid, it gives calcium chloride, water and carbon dioxide. So we are collecting a gas given off. The experiment was done at two different temperature. Like student maybe did experiment at 20 degrees or 30. So at two different experiments, student did this experiment. This is the experimental setup. The two experimental procedure, what happened? First, using a 50 cm cube measuring cylinder, like when they say 50 cm cube measuring cylinder, it means that is a maximum volume this measuring cylinder can measure. So using a 50 cm cube measuring cylinder, student added 25 cm cube of acid and it poured into a boiling tube. As you can see here, this is a boiling tube. A boiling tube, similar, same like a test tube. Then, but it is a bit wider, width is more as compared to normal test tube. Then the temperature of a dilute hydrochloric acid was measured using a thermometer. So we measure what is the temperature of hydrochloric acid. Then 10 gram of calcium carbonate was added and then the bung is placed. So this bung is placed and a gas is given off. The volume of a gas collected in a gas syringe was measured every 50 seconds for 250 seconds. Like student measure the volume first at beginning it will be 0, then measured after 50 seconds, then measured after 100 seconds, then 150 seconds, then 200 seconds, and 250. So student measure the volume after every 50 seconds till 250 seconds. But in experiment 2, what happened? Using a measuring cylinder, 25 cm cube of hydrochloric acid was poured. Look how we can improve this experimental accuracy. As you can see here in the question, they're using a measuring cylinder. So if they ask if we want to increase the experimental accuracy, so what we should do, we should use pipette or a burette, because 25 cm cube can accurately be measured by burette or a pipette, not a measuring cylinder. A dilute hydrochloric acid in a boiling tube which is warm with a Bunsen burner. The temperature of a dilute hydrochloric acid was measured using a thermometer. 10 grams of calcium carbonate was added the same way, and then student collect the volume of a gas in 250 cm cube, 250 seconds for 50 seconds interval. So after every 50 seconds, student record the volume of a gas. Use the diagram to complete the table of experiment 1. So what is the temperature reading of hydrochloric acid? What is the reading on the thermometer?
Uh, 23.
So it is 23. So reading temperature of a hydrochloric acid, that is 23 degrees. Then this is a table, like after every 50 seconds, student record the volume of a gas. The first one, because in the beginning there is no gas. What is the volume? Use a screen annotation to complete these volumes. What are the volumes? So each line is representing 2, so that is 12. Then 20, then 27, 32, 36. Yeah, that's right. So you just have to read the level, like you just have to read the volume, which is label, and just mention according to the reading shown. Then you have to complete a table for the second one. So what is the temperature reading for the second experiment? That is 41, 2, 3, 4. So that is 44. That's right. Then, yes, thank you. The next part, you have to complete the table. Use a screen annotation to complete the table. So the first one is 0, that's right. The second one is 25. The third one is 35. Then 40, then 40, and then also 40. So why the volume is same here? What is the reason? It shows that the reaction stops. Like the reactant, either acid, like it depends on what is a limiting reagent. If acid is a limiting reagent, acid is used up. If calcium carbonate is a limiting reagent, then calcium carbonate is used up. And it is obvious because the reaction is done at a high temperature. So it is obvious that the reaction will finish in a short time. As you can see here, it is 44, but in the experiment 2, it was only 23. Then plot the results of experiment 1 and experiment 2. So I will just sketch, because otherwise I have to use all the values. I can use the values. The graphs are, the labels are there. Like if you check the first value for experiment 1, the first value for experiment 1 was like 12. After 50 seconds, it was 12, then 20. So it was 12. Each box is representing 1. So 12. then it was 20, then it was, I guess, 27. I just remember the values which you mentioned. So it was 27, then 32 and 36 were there. So at 200, it is 32, and then 250, it is 36. So we'll draw a smooth line graph. And always, whenever you sketch, so this is experiment 1. Then we have to sketch for experiment 2. Experiment 2 was 25, 35, and then 40, 40, 40. So for experiment 2, 25, like this value was 25. Then it was 35. Then it was 40, 40, and 40. So, and this both started with 0. So a smooth line graph we will draw. And always, whenever you complete, you should always label. So this is experiment 2. Now the next part, I will keep the graph as it is and read the next part, because the next part is normally related to the graph. So they're asking, from your graph, deduce the volume of a gas collected in experiment 2 after 120 seconds. So in experiment 2 after 120 seconds, what was the volume? So how to work out that? First, we have to find where it is 120. So on x-axis, because 10 boxes equals to 50, so each box equal to 5. So this will be 105, 110, 115, and 120. So this value is 120. And for experiment 2, we have to find what is the volume of a gas when it is 120. So we draw a line from 120 for experiment 2 and work out the volume of gas. So it appeared to be 38. So 38 cm cube is the volume of the gas. The next part, explain how the results show that the reaction in experiment 2 has stopped. How these results shows that the reaction has stopped. How we can say that experiment 2, there is no more reaction or the reaction stopped. So you can clearly see here that the volume of the gas is not changing for experiment 2. So volume is not changing, volume is constant. Yeah, you can, that's the same idea, did not increase more or volume does not change. Both are the right ways. So you can mention here, because the volume of the gas is not changing or volume of a gas is not increasing, it means the reaction stops. Then predict the volume that would be collected in experiment 1 after 800 seconds. So after 800 seconds, what will be the approximate volume? Look, remember one thing, in experiment 1 and in experiment 2, we use the same amount of reactant. But what is the difference between the two reactions? Like in experiment 2, the maximum volume of a gas which we collect 40. So what should be the maximum volume of the gas which we should collect in experiment 1? That should also be 40. Why? Because the only thing which we change is the temperature. The temperature is changed for the two reactions. There is nothing else changed for the reaction. Like one of the reaction we carried out at 23 degrees centigrade, another one we carried out at 44 degrees centigrade. So can you predict the volume of a gas after 800 seconds? Because after 800 seconds, practically the reaction will stop. Like reaction will complete. And once the reaction is complete, the volume of a gas produced in experiment 1 should be equal to volume of a gas produced in experiment 2. And what is the reason for that? Because in both reactions, we are using a same amount of reactant, so we should get the same amount of product. So when you write the answer here, predict the volume of a gas after 800 seconds. So what will be there? That will also be 40 cm cube. And reason for that, because the reaction complete and same amount of reactant used in both experiment should give the same amount of final product or final volume of a gas. Then a student stated it would be improvement to measure the volume of a gas collected every 25 seconds. Like student collected for after 20 say after every 50 seconds, but student is saying that when he collect the gas after every 25 seconds, it will be more accurate. Explain why this is an improvement. Yeah, because what will happen, we'll have whenever we have more data, more information, we can sort out the trend in the experiment, we can identify the errors. So when we were taking like example after every 50 seconds, so how many values were recorded? 0 was there, 50, 100, 150, 200 and 250. So how many points we were having? 1 2 3 4 5 6 points were there. But if I record after every 25 seconds, so what will happen? 0 will be there, 25, 50, 75, 100, 125, 150, 175, 200, 225 and 250. So how many readings will be there? It will be approximately double. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So we'll have approximately 11 points. So 11 point, like we'll have more data, more information about the trend. So it will, that's why it will increase the, or it will improve the experimental accuracy. So if you want to, like how you will write, you will mention we'll have more points. So it will be like better graph can be plotted. Before that, when we were plotting a graph, so before when we were plotting a graph, how we were having few numbers, like few values. We were having few points, like example, one of the point was at 50, 1 point was at 100, 1 point is at 150, 1 point is 200, and 1 point is 250. But if we repeat the experiment with that, like we record the volume of a gas after every 25 seconds, so we'll have more points. So when we'll have more points, it will be easy to sketch a graph, easy to plot a graph with the more points as compared to few points. For example, if I say you have 1 point here, another point at this point, and plot a graph. So your graph will not be accurate because few points are there. But if I increase the number of the points, you can easily sketch or plot a graph. If you have more points, it will be convenient or easy to plot a graph with more points as compared to few points. So the answer when you mention, you'll mention because we'll have more points, like more readings will be there. So it will be easy to sketch the graph or plot the graph and see the trend. Is it clear? Then state two changes in the apparatus to improve the accuracy of the result if the experiment is repeated using a same thermometer. How we can change the apparatus? They give you the hint in the answer in the question that changing apparatus. So here we were using a measuring cylinder in the beginning of the question. we were using a measuring cylinder to measure the wall, like we were using a measuring cylinder to measure 25 cm cube. So what I should do, I should use a burette or a pipette to measure this 25 cm cube. That will be accurate. And second thing, what we can do, because we want to carry out a reaction at a fixed temperature, at a certain temperature, like if the first reaction is carried out at say 23, the other reaction at 44. So we don't want the reaction temperature to change during a reaction. So if we don't want the temperature to change during a reaction, so what we should do, we should insulate this boiling tube. So use insulation for the boiling tube so it does not lose energy to the surrounding, or the temperature of the mixture does not change. And second thing, you will use a pipette or a burette instead of measuring cylinder. As they already mentioned, we cannot change a thermometer. Otherwise, I can mention use more accurate thermometer or a thermocouple. But as they already specify that you cannot mention, the thermometer should be same. So we should change any other thing. So first change, what we should do, we should use a pipette to measure the volume accurately instead of measuring cylinder. And the second one, what we should do, we should use lagging or insulation. Then the last part, describe how the method used in experiment 2 could be changed so that the result can be obtained using a hydrochloric acid at 1 degree centigrade. Like how we can do the same experiment. So how I can make sure that I'm using a hydrochloric acid and the temperature of a hydrochloric acid is 1 degree centigrade. So whenever, like example, if we want to maintain a low temperature, remember in chemistry in a lab, there are two ways to maintain a temperature. One is like, if we want to maintain a low temperature, we use ice bath. And if we want to maintain a high temperature, we use a water bath. So 1 degree centigrade, it's a low temperature. If I want to maintain 1 degree centigrade, so what apparatus or what I should use? So I should use the ice bath and keep the test tube in the ice bath so that temperature will be around 1 degree centigrade.